Welcome to another SME Media webinar. I'm David Muller, Senior Editor, and today we'll explore Breaking the MES Mold, New Strategies for Manufacturing Excellence. This presentation is sponsored by Tulip, and we are lucky to be joined by Brian McGarvey, the company's Global Customer Success Lead, and Kailey Crothers, Tulip's Digital Transformation Engineering Lead. Welcome. We're happy to have you join us today.
Awesome. Thank you, David, for the introduction. As you mentioned, my name is Brian McGarvey. I lead our customer success team here at Tulip. What we do is we are the trusted advisors for our customers. We help them deploy, think through how to deploy our software into their operations and really get value out of Tulip. Kailey?
Yeah, thanks for that. Hey, everybody, Kailey Crothers. So I lead that digital transformation engineering group at Tulip, and we're focused working with manufacturers, many different industries and sizes, talking about what their current technology stack is and thinking about how to deploy and scale with a composable solution like Tulip.
Awesome, thanks. Just for a quick overview of kind of the topics we're going to discuss today. So really broken into 4 sections. The first is MES disruption. It's thinking about the new technologies and why a new approach to MES is kind of on the horizon and taking shape in the market. And Kailey will do a bit of a deep dive into what we call composability and this shift to composability and how composable app-based solutions kind of differ from point solutions or legacy solutions of the past. In the third section, we'll actually do a deep dive into an example of one of our customers in terms of how composability has been used in practice, which is a really cool story and excited to share. And then our final section here will be just on the future beyond MES, and then we'll open it up to Q&A. So before we get started, we're going to do a quick poll. So the poll is, how well is your MES working? The first option is, great, you have all the access to data and it helps your operations and when you need it. Second is, okay, we can operate, but it's not always efficient. C, not great, not efficient, may not handle all of your data operational needs. D, terrible, inactive, actively inhibits your productivity. And then E is like, you don't have one. And that's an acceptable answer as well. It's where a lot of our customers come from as well. So we'll leave this open for a couple seconds here, and then we'll see the results start coming through. All right, so not surprising. It looks like so far 64% don't have one, and then kind of like a healthy distribution across the other options. But know that you're not alone. We've seen this is typically where we've seen a lot of customers come to us with Kailey, at least in my experience, and I don't know if that's kind of where you see as well.
Yeah. So I think regardless of what camp you're in here on this poll, you'll find the content today helpful and educational.
Yeah. So thanks for sharing. So again, this first section is really on MES disruption. So we've really started to see what we call the frontline operations software market changing, and really changing in 4 different areas. The first is it's becoming more and more common and needed and asked for a cloud-based solution. So this really means is that multi-tenant SaaS is the go-to deployment for almost everyone. And then the second kind of pillar here is composability. Kailey will actually the next section will do a deep dive on this, but it's really what this really is about is taking a different approach to software solutioning as opposed to a monolithic system and a monolithic approach to solving problems. This third pillar here is, the expectation is that things on your shop floor are connected. And by things, that's really IoT. So obviously machines, sensors, and smart tools, that's not really anything that's necessarily novel or new. It's just becoming more of the expectation, and the barrier for doing so needs to be lowered. And then there's the other side of things. So the IT base, so being able to communicate and pass data with the rest of your tech stack. And so really the kind of this cloud-based open architecture, like open APIs, and being able to actually do this without needing an entire IT team to accomplish this is something that is fundamentally changing the market. And this fourth pillar here is cognitive. So built-in machine learning and generative AI, all backed by the data that your MES or in our case MES/applications are pulling off of the shop floor that were kind of locked and siloed on paper or in legacy systems. So these are really kind of what's shifting in the mindsets and both what our customers come to us expecting, as well as kind of what we see vendors and our obviously our software shifting towards. This is really backed by a couple things. The first is that, quite frankly, there's a new generation of digitally native workforce out there. 50, according to CFO Magazine, like 52% of Gen Xers said they would switch jobs for better tech, and then 70%, as you can see on the slide, of Gen Z employees would switch jobs for better tech. And so, really, what this is saying is like the expectation is that that people in the workforce have access to technology. It is everywhere around us in our daily lives. We're on Zoom calls right now. We have iPhones right next to us. But often when we go see, customers, like, again, the reality is like shop floors typically don't have these digital tools which enable, our frontline operators to excel and succeed at solving problems or ultimately being productive in their day-to-day jobs. And, we can kind of see this across many different personas, at least kind of the personas we talk to, process engineers who are trying to improve operations kind of on a fundamental basis, MES engineers who might be capturing and analyzing data, supervisors who are just trying to, hit performance targets or fundamentally understand, am I winning or losing the shift? Quality teams that are trying to track, escape rates and other metrics, and then IT who's just trying to, connect systems and protect data, probably a little more nuance to that, but at the high level, that's kind of, the types of personas that we see, and their expectations are shifting in terms of, what they need in the marketplace and what they, to be successful. From a business standpoint as well, there's, customer demands are growing complexity, which is driving, that it's not a nice to have, resilience in your manufacturing operations. This kind of comes in, many different areas, but to highlight on this slide, personalization and customized products. Of course, there's nuance in, in the specific industry we're talking about. By and large, that customization, the personalization, the different types of products, that's more rapid, shortened cycles for trends, technologies. And then obviously, especially over the last, 4-ish, 5 years, the supply chain disruptions. Obviously, a lot of the issues we've seen with COVID have subsided, but there's still a lot of unpredictability in there, whether that's from just like the systemic nature of different industries, such as, battery supply chains, or, currently like the geopolitical tensions that we're seeing around the world, it leads to a lot of uncertainty and kind of unpredictable nature of supply chains, which means that it's not a nice to have kind of this control tower or these types of digital solutions which allow you to be agile. What we typically see with customer or, prospects and, when we go visit customer sites initially is that the solutions that are out on their shop floor really aren't human focused and don't adapt well to these changes and these expectations. In my experience, almost 100% of the time it's, paper-based processes. So tracking production counts hour by hour. All of this is locked in on somebody's whiteboard or piece of paper, and then gets transcribed or transferred over into Excel or an Access database. So you're really not getting up-to-date information. You also see a smattering of like different point solutions, kind of across different capabilities. And then on the right, you have legacy, kind of legacy systems. Again, I've had that, seen kind of, like the matrix green screen of, just like it looks like it was coded in the 80s or 90s. The one guy or girl who knows how that system runs is just about to retire, and you're hoping that you can figure it out before that person retires, because that's the only person that knows what's really going on. So across kind of these three spectrums, it really lends to a situation where there's a need for new technology and a new approach to how to actually run operations in an efficient and agile manner. A couple words from industry analysts here. So this is from Gartner's, and so kind of their perspective is that there's a fundamental technological shift taking place in the MES market, driven by evolving technologies, new challenges, or that challenge the MES status quo, and driven by vendors with the agility and talent to accelerate the adoption of these technologies. And so you see that with something like our solution, as well as some of our peer vendors, in terms of being able to kind of match these changes and really challenging the market. So another perspective from Gartner, again, in terms of by 2025, which is closely approaching, at least 25% of manufacturing operations we'll use composable technology, and that's up from 2% in 2022. And on the right here, you can another kind of quick quote is seeing that an acceleration and transformation of traditional application architectures into composable applications. So basically seeing that, hey, there's this momentum shift into this new frame of reference, this way of building software within manufacturing that's taking place, and it's becoming an expectation. And last one from Gartner here. In general, it's fair to assume that the longer an MES has been in the market, the more effort that is needed to fundamentally re-architect it, which lends itself back to legacy vendors, the way that the solutions were originally developed, or if it's implemented on your shop floor, it doesn't really lend well to being able to just adapt that into the current ecosystem and architectures that are required of today. Really meaning that, lifting and shifting that solution is not really a viable option, because the data structures and the logic that were built in legacy systems, or the offerings that have originated in the 90s, they don't really fit into what's needed today. Based on the need for data availability, analytics, interconnected devices, the ability to connect to other business systems that are more modern. And so oftentimes it actually can make sense to, it's more costly to start to try and go in that endeavor than it is to re-architect, using a composable approach. Really going with the lift and shift approach really has no benefits of shifting to the cloud in terms of being, more performant and resilient. Being in this microsystem, microservices type of environment with composability, which we'll get into, it's ultimately less expensive long term, and is fundamentally a different way to think about how you have an open architecture to allow your tech stack to evolve, and ultimately you're not future-proofing yourself into a system that doesn't really adapt well to the expectations of your workforce, the expectations and changes that you see in your manufacturing operations as well. So with that, I'll shift it over to Kailey to discuss composability.
Cool. Thank you, Brian. So in this section, we're first going to give a little bit of a foundation of what is an MES, what does that market look like over the last few decades, and then we'll start to transition into how composability kind of breaks that traditional mold, and how we're helping customers get there. So I want to start off with this kind of intentionally broad definition. So this is definition from SAP of what an MES is. So a system that manages, monitors, and synchronizes the execution of real-time physical processes involved in transforming raw materials into intermediate and or finished goods. So what I like about this is it's not necessarily telling you exactly what an MES should do, what data it should be collecting or displaying. It doesn't have a reference in here to if it needs to be integrated with your ERP. It's really just getting at that an MES is a system that is involved with managing the execution of your manufacturing. So if we want to build on that definition and start to get a little bit more pointed, here you can see the ISA 95 automation pyramid. So this is from the International Society of Automation. It's a standard that governs integrating control systems and enterprise systems. So the quote above that, an MES bridges the gap between business and plant floor or process control systems. So business systems here is reflected also on the pyramid, representing ERPs. That's your financial system, often kind of managing like sales orders on the timeline of weeks or potentially longer. Plant floor systems are referencing more to your automation layer, your control systems, your PLCs, your machines. Often you're doing data collection, and your data acquisition is more on the timeline of seconds, potentially minutes. So really MES is there to bridge the gap between those two layers. And then moving into the kind of the right side quote that we have, MES applications also provide feedback on process performance and support component and material level traceability, genealogy, and integration with process history where required. So this is getting a lot more detailed, getting into that MES should be giving you, the user, specific details on what should be held within the system. So hopefully this was helpful in kind of level setting. I know we had the majority of folks here in the camp of not having an MES. So hopefully this was helpful to kind of level set for today's conversation. So now we're going to transition into a little bit more about the traditional architecture with MES and the traditional implementation approach that's been taken. So when we talk about traditional MES, we're going to be referencing it as legacy MES, the systems that have been around for the last few decades. And really the idea of this slide is to give you kind of a understanding of what that quote unquote mold has been in the market for those last few decades. So from a functionality standpoint, these MESs are built on a very rigid data structure. They are predefined, likely some relational database that is predetermined. So what that really means is the scope of data that you can collect from the system is also by nature predefined. And it's the same for users throughout the process. So it could be one dropdown that has 3 selections and you really want to add a 4th. That's really not an option in a way that is cheap and or quick. So there's a really large emphasis for the need for heavy customizations and even customizing customations. And that creates a pretty big emphasis on how much you lean on either vendors or system integrators. You can just kind of see that in the implementation side as well. It's very time consuming for updates. Most humans executing the manufacturing process are not doing the same thing with the same information. They don't have the same data capture needs or data display needs. If you think about it, like one of the fundamental complexities of manufacturing is just like the mere amount of variables that are present in operations between materials and tools and processes. There's just so much going on. And these legacy systems really enforce constraints on your processes, your users, and really hamstring you in terms of how quickly you can change. So for anyone on this call who has worked with legacy MES in the past, you are well aware of those challenges, I'm sure, and the expense that comes along with customizations. And if you think about it, it's actually kind of quite ironic. If you think about lean and you think about manufacturing best practices, continuous improvement is a fundamental concept. We are constantly encouraging change, constantly encouraging iterations and system improvements. But the irony is in that the systems that we use don't support that. So how can we get past this? This is kind of the mold that we've been given and the standard that we've kind of accepted. And composability really takes this and flips it on its head. I mean, it's a really just different approach to helping to support manufacturing execution. Back to those definitions that we covered previously. So getting more into, you probably heard the word composable enough already. You're like, okay, what is it? It can be used in a lot of different contexts. So today we're going to be focusing composability in the context of a system design principle, obviously here specifically for manufacturing systems. So this is a definition from Gartner. Composability is a system design principle involving selecting and assembling components to satisfy specific user requirements. Again, also intentionally vague. As we go through today, though, you'll start to demystify this and give you a better sense of truly what that means. So here's kind of both approaches at a high level, contrasted in the context of their data model. So what we already kind of went through, you have an ISA 95 standard, your data model is defined by your vendor, it is not extensible. A composable platform approach is very fundamentally different. So you are not inheriting a vendor-defined rigid data structure. You or your organization as the admin or the owner can start with flexible data models that you have full control over to change and iterate as either your processes evolve, as different requirements change, you can change the system with you. So this approach also gives you the freedom to extend the system. And that can be extending in a couple different contexts, whether that's in the functionality scope of what your composable platform is covering, but also through integrating to other technologies, whether that's your existing tech stack or technology that you're looking to adopt down the road. So to start to demystify composability here a little bit, we're going to talk about 3 fundamental pillars. First, decentralization. So this is all about taking or democratizing the technology, enabling folks that are closest to the operations to create human-centric solutions. Human-centric here also referring to user-centric. It feels like a modern technology that is easy to use. Adaptability, reducing the risk associated with the changes that face your business. How do you enable faster time to value and true resilience? And then flexibility, allowing organizations to pick solutions that fit their requirements. It's going to be a big emphasis today on empowering organizations through a composable platform to solve very specific to them business problems and how to prioritize them appropriately.
Yeah, I think that's another thing to add on, Kailey, is like the flexibility is like a huge component of this. Is you don't necessarily know what all of your problems are going to be in the future. And so you're able to, like, basically with the flexibility of the platform approach and composability, and you're able to help future-proof. Like, you know that you can adjust and adapt to the future problems you may face. Yeah,
and future-proofing is going to be a theme that we kind of come back to here today. It's a great add. So focusing first on decentralization. So we kind of have this nice loop here on the left-hand side for those who aren't familiar with Tulip's composable platform. That's a little GIF of the Tulip app editor. So it's a no-code platform or environment where you can build a workflow. So your quality engineers, your manufacturing engineers, your process engineers that don't have IT or software development experience can use this tool to create a solution that solves a very specific need. They can deploy that to the floor. They can instantly capture real-time process data, instantly capture frontline feedback from operators on the line, and then work that back into this continuous improvement loop that you're enabling. I also want to point out that this says maintaining governance. So with democratizing technology, you're not necessarily creating the Wild West. We could probably do an entire webinar here on how to govern a composable platform, but we're not doing that today. So we have tons of content. There's features and functionalities in the platform to help enable that at scale, whether it's basic things like user roles or it's permissions and versioning. We also have methodologies to kind of apply to the organizational structure involved in really scaling a composable platform. So if there's any questions on that, feel free to throw that in the QA. We're more than happy to follow up and help provide more detail there. So moving on to the second foundational piece here, adaptability. So focus on the most pressing challenges impacting your organization. So here on the left-hand side, you have that monolithic approach. So that's referring to the legacy systems that we just went over a few slides ago. It can take 12 to 18 months to implement one of these traditional MESs. So you better hope your process engineers don't necessarily change anything in that process within that time. So you have a very high risk go live because you're also maybe likely doing a cutover. So best case scenario on that go live is that your system meets the requirements that you had from over a year ago. This is contrasted with the right-hand side where you have a composable approach. So composable solutions are deployed in the time frame of weeks. I really want to emphasize that. The timelines that we're looking at here are night and day. It's also deployed in an agile fashion, so you can identify business solutions, go solve them quickly, and start immediately recognizing value. So each of these kind of components that you see in the composable approach are their own separate boxes on purpose. So it's really to emphasize that you can be solving unique business requirements that are independent of each other. But again, it's all one platform. And these solutions can be iterated on over time as V2 becomes more relevant, or if your process and business is demanding it, you have full freedom to go after that and appropriately kind of drive your roadmap.
Yeah, also just want to add into that, when Kailey mentioned earlier, like the human-centric aspect of this as well, the iterations can be, and we do see like iterations be on core functionality, like, maybe you integrate with another system on V2, or maybe you want to add certain functionality. But what's often very impactful is getting operator feedback. So having the system feed or having the system serve operators. And so when Kailey also mentioned that continuous improvement is a fundamental tenet of manufacturing, That's so true. But when operators are empowered to make recommendations and say, this would serve me better and I could be more efficient if if it gave me these options, that's a huge inflection point on shop floors when the entire team is empowered to have to make changes and recommendations, and those changes are implemented in the same day, as opposed to days, weeks, years, never, backlog tickets, whatever. It's pretty powerful to see along that front as well.
Yeah, definitely cannot emphasize enough that these are supposed to be human-centric solutions. Like, hopefully, 99% of folks could download the Uber app and call a car and go from point A to point B. They don't need a manual for it. They didn't need a training. No one needs to, well, unless you're, my mother, sometimes she needs some help. But the vast majority of folks can use it because it's human-centric. That same exact methodology should apply to manufacturing systems. There's no reason why not here in 2024. So moving along here into that third pillar, flexibility. So you have these various areas on the left-hand side, and you can kind of see where the scope of traditional MES fits across digital guidance through even compliance and traceability there. And then you have this whole host of other point solutions that might sit around it. So MES solves like a subset of issues, but there are other requirements outside of that kind of defined scope. So many companies often take a point solution approach to augment this. So this can create a couple different issues. One, you have an overwhelming amount of point solutions to manage. So there's the basic stuff that come along with that. Like, you've just created a lot of admin work. Your organization is going to have to deal with managing a lot of different vendor contracts, and you're really at risk for what's kind of defined as SaaS sprawl, or even potentially purchasing shelfware, where you might not need 100% of all of these point solutions. You just need a sliver of it. So by taking a platform approach, by going and using one composable platform, you can actually cover all of these areas, driven again by business requirement, business need. So you don't have to do it all at once. You can prioritize, what are the biggest thorns in your side? What is going to have the biggest dollar impact on your organization? So I want to emphasize here, you do not have to rip and replace an existing system. You can integrate to the tech stack that you have already today, whether that's a MES, whether that's existing point solutions, and you can start to build a composable solution around that. And then over time, start to bring things, more functionalities, more features online, kind of driven at your own timeline. Getting back to that future proofing that Brian also just mentioned a couple slides ago, it still sets you up, in a great position to adopt technology down the line. So, the rate of technology and just innovation period has really never been faster. So there's a lot of unknowns in that market. What's going to be easy to adopt, easy to deploy, and cost effective. Some of those are unknowns. So by taking a composable approach, you really set yourself up to be in best case scenario there. So that is it for going over the shift to composability that we've seen in the market. I'm going to pass it off to Brian to talk about composability in practice, specifically about one of our customers.
Awesome. Thanks, Kailey. So want to share just kind of an example of one of our customers, Stanley Black & Decker, who I've actually had the opportunity to work with for about 2.5 years now. And I think it's a really, really good story of, just this overall approach to digital transformation, but also kind of the composability aspect that we've been discussing today. So SPD is, on their way to implementing Tulip across 50 plus sites. As we discussed, there's like this governance aspect, right? There's, as Kailey mentioned. So they have a digital transformation team that's led by a director, and they have various application engineers and a program manager. But what this digital transformation team does is really provide standardization, share best practices, and scale effectively across their network. And they're kind of, what we dub internally as a center of excellence, and they call digital transformation. But it really helps define the left and right guardrails for a deployment, like a composable solution like Tulip. And just to kind of peek behind the curtain, kind of what they've done here is they've taken a multi-pronged approach to their basically how they solve problems. And so they have standard applications, which they develop and deploy and kind of maintain as a central repository. Things like 5S, SPC, NCMR, defect and scrap tracking, which are fairly can be scaled very quickly to different sites. There might not be a ton of differences between those sites. So they kind of maintain this internal library of these types of applications. And then this other pillar here, they have citizen developers. So they have people at sites across the world who develop and deploy applications which are tailored to solve very specific problems at their sites. And this is enabled by governance, and meaning that they have to pass certain stage gates of a certification to make sure that they understand what they're doing with a platform like Tulip and that they're trusted to deploy these solutions into production. On the right, then there's more, or this third pillar, there's enterprise solutions. So these are more systemic solutions for digitizing manual processes. So think, BBSOs, behavior-based safety audits, tiered KPI collections, as well as all of their returns processing. And then they also have key focus sites that the digital transformation team may help enable that across their network. So they'll go to, they'll help focus on those sites and help them develop very specific solutions, which are potentially unique to their processes or the products that they're making. Just a couple examples of applications which are developed over different teams. On the left, you have just examples of that 5S application, that digital dashboard, digital and-on. Like these are digital transformation team-led apps. And on the right, citizen development-led apps. So quality and SPC recording, which started off at a site in one of their UK facilities, and then it was actually shared back to the central team and is now a best practice app that's shared globally. And so that's like the power, meaning that hey, the creativity is unlocked with certain people in their network, and then it gets shared back, and they can scale across many of their sites. Other examples of this are very simple assembly hour by hour boards. Now, that's kind of like the structural framework in the background of some of the stuff that goes on at SPD. But do want to share, a story of one of their sites in Mexico. So this site is around 400 operators, and they actually make outdoor power tools. So the battery-operated leaf blowers and weed whackers that you go see if you went to a Lowe's or a Home Depot. To be clear, this site runs on Tulip. 95% of the employees there touch Tulip every day. And really what they've done is they've developed an ecosystem of applications and dashboards that have amounted to a composable manufacturing execution system. It allows the team there to basically control their own destiny, if I had to kind of summarize it. They really have real-time visibility into operations, production, management, and continuous insights. They really built this system over a matter of 3 months. Just to kind of put in context, the level that they're operating at, this was a greenfield site, so there wasn't a nice before story. But the site's scrap goal rate was 5%, and the stretch goal was 3%, and they were consistently operating at 0.2%. So that's kind of the level of performance that they were able to achieve. Now, this site is clearly a model for probably most manufacturers in the world, but certainly within the SPD network. But it's kind of another really cool insight is, obviously Tulip is a no-code application platform. So when we say, app builders, that's what we mean is people that are empowered on their shop floor or the supervisors to build these applications in a controlled manner. But their culture was really around empowering application builders. They did have a core team of centralized application builders that built the core functionality of what they wanted to do for production. But then they basically trained over 50% of their staff in terms of what Tulip is capable of. Not with the intention that they're all going to be application builders. Most of them, or some of them, did become application builders, but it was really so that their team was aware of the power of the composable tool which at their disposal. So when they saw a problem, they know how it could be solved. So they were very intentional with creating a training, a site-specific training curriculum, where employees would actually get certificates, and I actually had a chance to go visit them. They proudly displayed those on their, within their cubicles in their offices. They were certified, within for their basic app building certifications in Tulip. They held app building competitions every 6 months, in which the plant manager would recognize the top applications. And they also had from like a continuous improvement Kaizen type of mentality. They actually built an improvement idea submission portal that they had on the shop floor for operators to provide that type of like ideas of how to improve things. So it was like when I talked earlier about this inflection point of a cultural, this cultural inflection point of continuous improvement, like this is the type of thing that I was talking about.
Brian, I also just want to add one thing there. If you think back to one of the first slides we showed, it had a mix of paper processes, point solutions, and legacy systems. So the story there of training, all of their engineering staff to have that tool on their tool belt, so when they see a problem, they're going to the same consistent tool to solve it. It has a lot of value. So this is removing these one-off Excel sheets, these random paper processes. They all come from a good place. You have hungry engineers who want to make their processes better. But by having a composable solution that's democratized, they'll try to stop using all the marketing language, but by having an accessible tool in standardizing your staff around this is the tool that we go to quickly solve problems, it creates a lot more cohesion, makes data more available, a lot of value to be gained over time.
Yeah, exactly. So when we talked about kind of that central core app builders at the site who again were operating kind of within the left and right bounds at the digital transformation team, and corporate digital transformation team saying, hey, here's the standards, here's how you can use this tool at your facilities. Then we kind of go down to the site level saying, okay, here's the core app builders at the site. These are some of the types of applications that they built. Again, not all at once. So when Kailey showed like that, little bricks of knowns and unknowns building up over time, like these are like, all of these are like those little bricks being added over a course of 3 to 4 months. So in the top left there, you see guided assembly work instructions. Again, they have people that are building, the same thing over and over again. So it's not a very complex build. So they don't need to have, be clicking through work instructions. They need access to the most recent work instruction. And so they were able to achieve that by a very simple integration with their PLM. The center top is this visual management production tracking. So quite simply, again, just am I winning or losing the shift? Am I winning or losing the hour? What am I supposed to be building and how much am I supposed to build it? Like being able to answer those simple questions for the teams and the production cells is just, it's amazing to see facilities that do have that and the facilities that don't have that. And it just keeps everybody on the same page. The top right there is, being able to select and show work orders from SAP. So again, knowing what is the site supposed to build today and manufacture? What is the line supposed to manufacture? Coming from your ERP as a single source of truth and not duplicating all of that. Bottom left, just example of scrap and rework stations, being able to track scrap and rework defects, and also being able to basically get that information further up the line if there's issues upstream of the manufacturing process. So a good example of that is in that center bottom there. So learning and Andon, they using one of our library applications, we're able to integrate with Slack. That's what the site used anyway for communications. And they also integrated with like the Andon lights across the facility. But basically, it's just enabling communication across teams without having to go face to face and talk to them. And then the bottom right, this is an example of kind of this unique problem solving. They had a challenge where they were going over on the amount of time they were allocated for when receiving materials. The trucks had to be unloaded a certain amount of time. They were using a whiteboard before. They basically and getting charged thousands of dollars, like a lot of money. They were able to solve a problem that was somewhat unique to their site, very simply with an application that took about 2 hours and saved it's incredible the amount of return they were able to get off of not having to have this problem anymore. So before it was daily. After this, they hadn't had a single overrun. And so again, it's this is the type of thing where this bottom right application was then surfaced back to the digital transformation team and is able to be scaled across their network because you can bet that that's not the only site that has that challenge. So all of these applications that I showed on the previous slide are all flowing into a similar data architecture. They're all ecosystem of applications. What this enables them to do is to have digital tier boards. So they run their daily stand-ups and their tier 2 and tier 3 meetings using these boards. And so they've also integrated this with finance data. So they're getting plant performance data as well as the financial aspect of things and marrying them together. And you're able to see real-time visibility against their KPIs for their site, for their value streams. Again, along the same theme of continuous improvement and lean principles, on the right here is an example of when you click on, if you were to click on one of those buttons on the board on the left, it would take you to accountability boards. So what this is really showing is the ability to track problems and make sure that progression is being made against those problems. And so just like a cool thing that they did. Again, the creativity of our customers is always remarkable. They had a system where they get 3 red X's each time. Basically, you get a red X each meeting that you don't have sufficient progress made. If you get 3 red X's, then it gets escalated to a higher tier, so the plant manager. Again, when I had a chance to speak with the plant manager, it wasn't because to crush anybody. It was because the mentality was, hey, this is manufacturing. We're gonna have problems. It's our job to solve them, and we need to make progress on those problems. So it was, again, this cultural inflection point of being able to use a tool to effectively manage their operations. Just another example of kind of what this looks like in reality. Again, we're harping on composability, but this is what a composable system looks like in practice with these applications and the ability to solve problems that are all feeding a common data structure that are allowing the teams to actually take action and own their destiny. On like the first slide, I'd shared that there was 50% of their staff was trained on Tulip. These are examples of problems that people didn't know they had, but now had a tool to go solve them. So they make batteries there for your power tools. There's certain quality standards for temperature and humidity, so they wanted to monitor those and being able to easily integrate with the temperature and humidity sensors at the plant. To make sure that if there was any quality defects, that they were able to go back and verify that it wasn't based off of temperature humidity controls. And then also if they're going out of bounds on those, to alert the right people at the right time to get those things back in control. You can see the other types of applications here. You have spare parts, facilities tickets, MRO. These are all things that might have been managed in Excel or disparate systems, but now they're integrated with their production. And again, these didn't start on day 1. They didn't start on month 3. These are things that people came up with and said, I have a problem and I can solve them in a coherent, composable way with some governance guidelines. So for the last section here, I'll turn it over to Kailey to discuss the future beyond MES.
Great. So just kind of recapping here as we're coming to the end, a couple principles on breaking the mold of traditional MES. So the first one being systems should support business strategies and value creation, meaning you should have a system that allows you to target very specific business problems and target them appropriately. Second one being embrace approaches that best support your organization, focus on human centricity and let engineers be engineers, and think about how to future-proof your technology architecture and tools. So avoid getting locked in with limitations of what you can or potentially cannot do. So I want to flash this quickly. This is Tulip's Composable MES app suite. So for anyone who has some background on Tulip, we have something called our Tulip library, which is different integrations and applications and templates that we provide our customer base for free. The Composable MES app suite is a set or suite of applications that stretch over a couple different categories. Production management, inventory, compliance and traceability, and then quality, which can be applied to everything, of course. These come pre-built on what we call a common data model. So they are tables that you can adjust, you can extend, you can remove what you don't need, but it's a good starter plate for the various use cases here. They're also built with our Composable MES best practices, so they're built for scale. And they're just various different templates that you can get started with today. There was actually a question in the chat, not to jump ahead, but under the composability platform or the individual modules confined to the limits of the traditional, just that they are more. I really want to emphasize though, Tulip does not have modules. There is not a production management function that you turn on or purchase in Tulip. It's just a fundamental toolbox that you're provided with that then you can use to apply to these different use cases, or again, to solve whatever problems you're looking to solve.
Thanks, Kailey. Well, yeah, so now obviously the time for a few questions. We do have a few in the Q&A.
Yeah, thank you. Thanks for the insightful discussion and presentation. So first question, what apps do customers usually deploy first?
Yeah, great question. I'd say it really depends on the industry. I'll speak. My background is more in general manufacturing. We also have a lot of customers that are in life sciences, so just kind of the fundamental use cases are a little bit different. But from the general manufacturing side, and Kailey, I'm sure you may have a different perspective. When we get to walk the shop floor with customers, and kind of this production level visibility, like sick boards are all on paper or on whiteboards. Kind of the best that a lot of production managers have is like to understand how they did at the end of the day, and they didn't really know, are they able, like, how are they progressing throughout the production day, and by the time they actually know what they did, it's that's been too late, and the best that they can do is try again tomorrow. And so what I like to do is, like, a very, very simple application is just start tracking production. It doesn't have to be super complicated. You can grow into something that is more unique and bespoke, but just, again, answering the question of, like, am I winning or losing the shift is often, like, extremely valuable. And then also tracking, like, scrap. I think that's, like, quality defects. Like, there's a ton of really, really powerful insights that you can get, as well as, like, kind of that and-on communication across, like, teams, which is often very quickly unlocked with those types of use cases. Kailey, anything else to add there?
Yeah, I would double down on production visibility. I think is the most common, mostly because just so many manufacturers don't have it. Exactly what Brian said. Like, are we winning or losing on the day? Can't answer that in real time. I think to maybe extend off of that, though, ease of implementation is also something to consider, because composable solutions can be deployed in the time frame of weeks, not months, not years. You want to bite off something that has a realistic ease of implementation, so you can get that on the floor. What you have as V1 will not be your final version. So prioritizing speed there is also important.
Yep.
Okay, next question. How can we integrate composability into our existing infrastructure without disrupting workflows?
Yeah, Brian, I can take this one first. It obviously depends on where you're at today. I know based on the poll, we had majority folks know MES, and then kind of another chunk that had different satisfaction levels there. It depends on where you're at. I mean, you definitely do not have to do a large cutover system replacement. We actually very much encourage against that. So maybe it starts on, you pick one line. Maybe it's a line that you have a lot of quality issues with, or it's a newer line, for whatever reason it may be. Maybe you start digitizing that, deploying the required functionality there, and then maybe scaling that across many lines. There's a few different approaches, very dependent on your current state.
Yeah, agreed. It really depends on where you are as a customer, what your tech stack is, and what I've seen, our customers be able to achieve is that there's our prospective customers are across all that spectrum, right, from of like that landscape. So we can meet you where you are, and you can grow into it. It doesn't have to be this massive system cutover.
Okay, great. And another question from attendees: can applications be built to be both dashboards pulling data, as well as user interfaces to push data into the data lake?
Absolutely.
Yeah. So the blunt answer is yes. And that's where, like, the flexibility of, again, well, obviously we work at Tulip, so I'll love to speak about it, but that's where you get to make those design choices for when it makes sense for you to have that. And it's very easy to build the type of application you just described. And yeah, many customers have been very successful with, like, that exact thing. And also you can kind of go to the left and right of that, where it's only a dashboard or it's only a user interface. You can make those choices, and you can also decide to change those choices in the future, which is, again, really, really powerful. And then being able to push and pull that data to a data lake or other systems is, again, it's just something that is, very, very easy to do.
And in many cases, it's both. I mean, you have analytics embedded directly into your workflow for, maybe it's an app that's prompting for data collection, what have you, but it also has analytics embedded into it. So you're not just relying on the dashboards on the line, it's actually on your interface, the context of how your shift is performances.
Yeah.
Okay, great. Next question. Are there industry-specific considerations or best practices when adopting these strategies in a manufacturing environment?
Yeah, I can go first. I think the answer is yes. Again, I alluded to it earlier. I think in my mind, the biggest line in the sand is between general manufacturing and life sciences, mainly because of the GXP requirements for the life science industry. When you're making pharmaceuticals, med devices, there's just the traceability, the compliance aspect for FDA type of audits that, again, we can serve and we do serve very well. But oftentimes we don't see those types of requirements for, a tool maker or, some other type of general manufacturing industry. Again, that's not mutually exclusive, but that's usually the line in the sand. But to be clear, we can serve both industries and do so very well.
Yeah.
Okay, great. Another question. What role does employee training and adoption play in maximizing the benefits of composability in frontline operations?
Yeah. I think it plays a large role. Not to say that it's a hard thing, but we have a lot of self-serve tools, university, where you can take courses, learn how to use Tulip, knowledge-based articles. You're trying to do a specific analytic. How do I do that? Very similar to how you Google things. I think it's important as an organization, to really unlock the potential that comes with having a composable solution, to really also have ownership over it. So to have those citizen developers to truly and fluently understand how to use the tool, I think that is a huge factor in the success of adoption.
Yeah, absolutely. Just to add on to what Kailey said, the entire point of a no-code solution like Tulip is to be approachable for those who may not know code. So, and really for those that are closest to the problem within the four walls of manufacturing plant. Those tend, advanced manufacturing engineers, quality supervisors, some know code inside and out, but others don't. But they do know if then when logic, and so that's where building and solving problems in Tulip, that's where they're often the most successful. And to Kailey's point, Tulip University, knowledge-based articles, my team, the customer success team, helping partner with those that are implementing and wielding Tulip. That's kind of how we see customers be successful.
Yeah.
Okay, great. No further questions at this time. So I want to thank Brian and Kailey for joining us today. I also want to thank our attendees for your participation. We hope you found the content valuable and will join us again soon. Until then, remember that SME and SME Media are here to help you stay up to date on all things manufacturing. You can find links to podcasts, webinars, publications, and news by visiting us at advancedmanufacturing.org. Thank you.